All right, so definite integrals, if f is continuous, then we realize that this area between a and b under the curve, between the curve and the x-axis, is actually represented by this integral, and we've talked about that already, all right? So then the area under the graph from f, of f from a to b is given by that. All right, so this is representing an area, and we've talked about that many times. So that's a little bit of review. Area has to be positive. However, integrals can be negative. So technically, this represents an area, but this is called an integral, okay? It does represent areas, but it is called an integral. Why would it be negative? Because maybe the area we're finding is underneath. So if the area is underneath, it'd be a negative quantity. So it's a negative integral, but the area is technically positive, all right? So some rules of definite integrals, and these rules kind of make sense. So the first one is going to be, if you are finding the area from A to A, if I said start at A and stop at A, your area is 0. That only makes sense, okay? And then this would be the same as if I switch the A and the B, and if I put a negative in front. So if I get the integral the other way, if you put it into your calculator the other way, if you put like a 2 and a 5, and then in your calculator you switch it and put a 5 and a 2, you'll see that one is the opposite of the other, okay? So normally we go smaller number to bigger number, but if you do bigger number to smaller number, you'll have a negative answer. So the ones of you who keep giving me a bigger number at the bottom, you're making your answer opposite of what it's supposed to be, okay? So it's like, I'm giving you $50 versus you giving me $50. That's very different. Okay, the other thing is, just like derivatives, you can take a constant k or c or whatever you want to call it. You can take this constant and you can factor it out. So you can just, if there's a 2 in there, 2 times whatever quantity, you can take that 2 out and then just keep it out there and multiply it at the end, okay? So a constant you can factor out. Okay, and then the other one is, if we know for sure that B is between A and C, then from A to B and then B to C, if we add those together, those areas together, it's the same as if we go from A to C. So C would have to be over here. C can't be over here, right? B would have to be between A and C. So that is another rule. Is there more? No, I think that's it. Okay, so one thing that we've done is something like this. So, I mean, I know you can do this by hand, okay? I know you can do this by hand, but another way that you can do, instead of finding the antiderivative and plugging it in, is it is possible, you guys know, to actually graph this line, and then from 0 to 3, you literally find that triangle and then find that rectangle and add them together, and you will get 24. And when this is really important, it's not important here, okay? But when it's really important is when you have a question that has radicals. Put a little star here and highlight it. So this is the homework that we had, right? But our homework, well, actually our homework is something like this. So then I give you that extra problem as well. So realize that anytime you have an absolute value, draw it. Don't find this by hand, okay? So draw it and then find the area of the triangles or rectangles or whatever you need to do, and then just add those together. It's so much easier that way. Isn't that easier? If you find the area, like, so this is an area of what, 2 and 2, and you add it together and you get 4. Okay, this is the other way. I don't think this is a good idea. Some of you will do this, but you shouldn't. So some of you will do this because you're going to be like, oh, that's -2 to 0, and that's a line with the slope of -x, plus from 0 to 2, and that's a line with the slope of x. You can do this. You can break it up and do this, and you can find the right answer, and it's fine. But it's so much easier to find areas for absolute values, all right? Okay, so here's where the rules come in that we were just talking about. So it says from -1 to 1 of f, you have an area of 5. from 1 to 4 of f, okay, that looks good so far. We have a negative 2. All right, so the best way to do this, by the way, is to write it down. So from here, I realized from here all the way to here, what would I do? I would add them together, okay? So I would draw a picture or write it down or something. Okay, and then this is a different function. Be very careful. This is negative 1 to 1. What do I mean by draw a picture, by the way? So if I were going to represent this with a picture, so negative 1 to 1 to 4. If I was going to draw f of x, I would make sure that this is like above, maybe somewhere like this, and then maybe something like this. So here's what I mean. This area is obviously positive. It makes sense that it would be a positive 5. And then this area from 1 to 4, see how it's more negative than positive? So that's why it makes sense that that would be negative 2. So I would, draw myself a picture if I'm not sure. Some of you are like, I don't need to draw a picture, Ms. Chan. That's fine. But I'm telling you, this works too. Okay, so first couple questions. What if you go from 4 to 1 of this? Okay, well, you should be able to do that really quickly. Okay, you should know the answer, yes? What if you go from negative 1 all the way to 4? From negative 1 all the way to 4, you should be able to do that as well, yes? So you should just be able to put a negative in front of this. Can you write this down? Even if you put 2 as your answer, can you just write this, please, 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 on your notes? Okay, and then this one, you're adding those 2 together. So really, you're adding a 5 and a negative 2, and then you get a 3. Okay, these are your notes, so you're writing this out. If you just write 3, you're not going to get full credit. Okay, I know, I'm a jerk. All right, and then, whoops, I showed you the answer for this one. Okay, let's do this one. Let's do this one first, yes. So this is negative 1 to 2. So this is, all we know is from negative 1 to 1, I have a 7. We don't know that it goes to 2. That's why it's no solution. Okay, so D is no solution. For this one, I would factor out the 3, and then I would separate the minus into another integral, because you can separate this into 2 integrals, and then separate out the minus, and then separate out the 2. So here's what I mean. So I would write it this way. So this is much easier for me to see what's going on. So take out the 3, put a minus, rewrite this as its own integral from negative 1 to 1, and bring out the 2. Okay, so now I can just literally substitute. So what is this? It's 5. What is this? It's 7. So I literally substitute, and then I get a 1. Okay. This one right here, from 0 to 1. From 0 to 1. Huh. Do I have that? No, I have from negative 1 to 1. And then this says from 2 to 2. Oh, well, yeah, you can find this, okay? But let's think about this one. So that one's 0, it has to be 0 from 2 to 2. This one, we don't know. So here is a possibility, right? So we don't actually know 0 to 1. So we have no idea. You can't say that you know that quantity, right? All you know is this quantity. So that's why that one is also no solution. Okay, are there more? Oh, given. Okay, so you can do this one. This one's actually kind of review. So a lot of the rest are kind of review. So given, you have this, you have this. Find 0 to 10. Okay, so I want you to think about 0 to 10. How would you set that up? So from 0 to 6, I use this function. From 6 to 10, I would have to use this function. Okay, so then I break it up. So 0 to 6 and 6 to 10. And then I can either draw pictures or, it's pretty quick actually to find the antiderivatives and to plug in. Obviously I made a mistake, but there you go. And then you have your final answer. Okay, so jot that down. Hopefully that's right. I'm assuming it is because I already wrote on it, but sometimes weird things happen. Okay, so there you go. Make sure that you, if you're going from 0 to 10, really look at those values. All right. Okay, on the back. So I think you can do this on your own. So you find all of these areas. You didn't just copy me, right? You literally find the triangle area. You find half a circle with a radius of 1. you find that triangle, you find that triangle, and you find that triangle, right? You have a base and a height for all the triangles. Okay, find the areas. And then from -1 to 0, what is that area? You can do it. From -1 to 4, what is the area? So you just, so it's half of that. There you go, from -1 to 1. So my answers. And then just kind of think about it first. From -3 all the way to 6, you're adding and you're subtracting. And then from -1 all the way to 7, you're adding and you're subtracting. So be careful about it. Don't just do it in your head, like actually write it out. And then you have your final answers. And then I think this is the last two for this one. Find the absolute value. Oh, this one's good. Oh, these two are so good, guys. Okay, find the absolute value from -3 to 7. Okay, -3 to 7. If you're finding the absolute value of the function, what do you think you do? Remember what we did for speed versus velocity? Speed is the absolute value of velocity. You take that graph, everything on the bottom, you bounce it up. So literally everything becomes positive because that becomes a +3 and that becomes a +1. So then you just make everything positive, add it all together. Okay, we'll check our answer in a second. This one I love. I like this question. I'm going to ask you questions like this. So when you do this, you start with separating them because you can. So there's a plus. So really you're thinking about this as two antiderivatives. Okay, this is using the picture. You can find the answer to this. This is not using the picture, but how can you find the antiderivative of 2? It's 2x. And then, so this one you just add all together. This one, you find the antiderivative and you plug it in, and then you get your final answer. You can do it. Okay, and then it's been a while, so I just wanted to remind you, I think on the homework this is, coming up, and that's why I did this. But it keeps coming back, okay? It's been a while. What is the derivative of a number to like an x power, like 3 to the x power? So e to the x is easy. The derivative of e to the something is e to the something times box prime. But remember, if this is not e, if it's just another number, 5 to the x power, it'd be 5 to the x ln of 5 times the derivative of x. So then what would be the antiderivative? Okay, so the antiderivative, it starts with this same thing, right? So I would do it like an e problem. So I would start it like this, and then I would, just like before, I would use my box method. So from here, what is the derivative of that? So I think back, it's going to be 3 to the 2x times ln of 3 times 2. What do you set that equal to? You set it equal to OG, right there. And then, so you set it equal to that one, and then you solve, and I know it's weird, but when you solve, your box equals 1 divided by 2 times the ln of 3, because this gets divided to the other side. So final answer is this plugged into the front, or you can just, write it on the bottom. So final answer. So it's the same as this, but with the box in front. Okay? Okay, for number 7 and 8 and 9, I'm actually going to put those on the homework helpline, and then you guys can do those on the homework helpline. I'll give you a hint. For number 7, my hint is long division. For number, any other hints? No, I give you no other hints. So 7, 8, and 9, homework helpline. Okay, I will see you tomorrow, and we'll talk about these notes, okay?